Hey, everybody, I'd like to welcome you to the December 2023 edition of the Audio Programmer Meetup. I'm Josh. I'm the founder of the Audio Programmer, and every second Tuesday of the month, we come together to talk about all things audio software development. And I have some very special guests with me. We have Matthijs Hollemans, who is, as some of you may know, authored the recent book that we came out with earlier last week. So he's here to tell us a little bit more about the book. Ooh, he's got a copy with him as well. So we're going to talk a little bit about that. By the way, a little plug. We're going to be doing a couple little plugs today. If you're interested in the book, we have it, the link to it in the video description. So thank you very much for supporting, for all the people who have bought it so far. And yeah, please support it if you haven't got it. It's a great resource if you're looking to get into audio software development, looking to take your next steps. Maybe you've watched some of my video tutorials and are looking to get more in depth with it. And that's a great resource for it. So I also have the AV8 audio team here with me, Shane Nolan and Steve Lascos. So they're tuning in as well, and they have created this really awesome ecosystem called Multiverse. So it's a guitar pedal where you can actually prototype and load your own DSP, create your own guitar effects. So they're going to talk a little bit about how to do that. And while we have them here, we actually have a special discount that they're offering for anybody who's tuning in for the Multiverse Tech pedal, and they're giving a very generous discount off of the pedal. And there's the product code in the video description below, and they'll tell you all about what the pedal does and why you should get one. So welcome, AV8 Audio.
Thank you.
And we have Brad Howes. So I just recently found out that Brad Howes is actually the creator of SoundFont. So if you ever used a SFZ player online, Brad Howes is the creator of one of the leading ones called SoundFonts. So he's here, and he's going to talk about AUV3 APIs and basically how to start working with them. So he's going to give us an introduction to how to start working with those Mac specific APIs. Many people ask us what happens under the hood of Juice and the awesome work that they do, and being able to abstract these cross-platform APIs, abstract those out, and create that foundational layer that so many people use. And so Brad is going to show us a little bit about what needs to happen under the hood if you want to interact directly with those APIs themselves. So welcome. If you're not part of our community, please join our audio programmer community. We've just broken 10,000 members on our Discord. So, very awesome. It's been something that we've been doing since 2017, and amazing to see where it's gone to now. So thank you for everybody who's joined. And if you're not part of the community yet, join us. It's free. You can join us on the audioprogrammer.com/community. And with that, we will go ahead and jump straight into our first talk with Matthijs. And so he's going to talk about his book, Creating Synthesizer Plugins with C++ and Juice. Over to you, Matthijs.
Thank you very much. As you said, I wrote a book. It's called, I don't know, does it show up in reverse? Probably does. It's called Creating Synthesizer Plugins with C++ and Juice. This here is the paperback version. We also have ebook versions, PDF, EPUB. But the paperback came out really nice, so I have to thank Josh for that, because he put that together, and I'm really proud of it. It's really cool book. In this talk, I just want to talk a little bit about the book, what it is, who the book is for. I want to give you a little audio demo of the plugin that we built in the book. And then I just want to go through the book in a bit more detail, just to give you a sense of what's in the book and make you decide if the book is something that you would be interested in. So I will share my screen now, which is a bit easier than flipping through the book, the physical book. So here I have the PDF version of the book. So I just want to scroll through it a little bit, just to make sure, give you a sense of what's in the book. I'm sure if you are really fast, you could probably read along, but I'll highlight some interesting parts of the book later. But the main thing I want to show is that there's a lot of pictures in the book. There's also a lot of source code in the book, and not a lot of math. I think that's one of the benefits of this book. So I want to talk a little bit about what the book is about and who the book is for. So the title kind of gives it away. It's about creating synthesizer plugins with C++ and Juice. But it's really important to understand it's like a tutorial style book, which means we go step by step, starting from a blank project and then filling in all the pieces you need. And at the end, we end up with a complete synthesizer plugin. And I'll be happy to show you that finished plugin in a little bit. So you can see, what we build towards in the book. But it's the book is written for beginners. So if you've never done any audio programming before, or if you've never done anything with synths before, that's really who the book is for. It's really written in a hands-on style. So you're supposed to read it from beginning to end and follow along with all the explanations and type in all the source code. And that's how we build up your knowledge of how to make synths. It's really very practical, hands-on tutorial style book. It's not a reference book so much. The synthesizer that we will build is a virtual analog synth. And you have to think about synths that were, synths you could buy in the 60s and 70s and 80s. That style of synthesizer is what we're building. I'll explain a little bit more exactly what that means for the synthesizer. But it's not a book about all possible ways to build synthesizers. There's loads of ways you can build synths, and we're just focusing on one particular way. But it's also very a fundamental knowledge of how to build synths. So once you understand how to build this virtual analog synth, you're in a good place to go on to like an FM synthesizer or a wavetable synthesizer or physical modeling synth. But you need to know these basics anyway that we will learn in this book. So I think it's a good starting point for people who want to learn about building synths, even if you're not really interested in building a virtual analog synth. The title also says C++, which means that we use the programming language C++. It's not necessarily the best language for beginners, but you do need to know, at least a little bit about programming in order to get the most out of this book. It's okay if you're not super familiar with C++, because we're not going to go into all the possible features of C++. We only use like the bare minimum that we need to get by. But if you've never programmed before, then it might be a bit much because we don't really go into all the details about the language. Now, there's lots, like I said, there's lots of pictures. For example, like we're gonna, let me scroll quickly through some examples. So, for example, whenever we need to do something in the IDE or with other tools, there are pictures in the book that explain what things to click on and so on. So it still takes you by the hand. It still explains everything you need to know. So it's fine if you're not super familiar with some of these tools. Everything's explained, but I can't really go into the teaching you how to program from scratch. So it's nice if you bring some programming knowledge if you already have some programming knowledge. And if you don't, the book does has links to places where you can learn about C++ and so on. But to make the most out of this book, you should know how to program a little bit already. The last thing on the cover is Juice. Now, Juice is an audio programming framework, and we use it mostly for the plumbing. What I mean by this is we're going to make plugins, and there's lots of different plugin formats, and we don't want to deal with all that stuff. We just want to deal with how do you write a synth. So we use Juice to take care of all the annoying bits for us so that we can focus on the audio programming. Juice also has this library of DSP functionality, but we're not using any of that. We're writing all of the DSP code, all of the audio programming code from scratch, because that gives you the best knowledge of how to do audio programming. I mean, Juice is great, the DSP library is great, but in order to really learn how everything works, we're going to write everything from scratch. So even if you don't really want to use Juice or can't use Juice, maybe you want to use some other framework like iPlug or something, the book still is useful to you, because most of the interesting bits, the interesting code is all independent of the framework. But the reason that we use Juice, the reason we use C++ is because these are the standards of audio development, right? So if you want to get a job as an audio developer, you will probably end up using C++ and Juice. By the end of this book, you should have a pretty good sense of what digital audio is, how to synthesize sounds, how plugins work. It's really supposed to be an introduction to the world of plugin development by building a synth from scratch. And with that, I would like to, oh, I'm actually forgetting something. We do have the source code available. It's on GitHub. If you're interested in checking out the plugin, but you don't really haven't decided if you want to check out the book, if you want to get the book or not, you can go on GitHub. We have all the source code from the book is there. You can find it by chapter. So if I look at like chapter 2, there's a source code. It's really very simple. We haven't done much yet, but a few chapters later, like chapter 6, it already starts to be, we already have a whole bunch of source code. And by the time the project is finished, we have like a fairly decent amount of code that we've written together. You can also check out some audio demos on the GitHub page. So I've got some MP3 files that were made with this synth, no other effects were used. So that's also something you might want to check out. But I will actually give you a live demo of the synth in action right now. So that might be more interesting than listening to some of these demos. So I'll hide some of these things and I'll bring up the synth. Okay, so what you see here is a simple audio host program. It's called Audio Plugin Host. It comes with Juice, and you can use this to test out your synths. It's really useful for things like debugging synthesizers or any plugins. The synth that we will build, it will work in any host. So I've tested it in Logic and Reaper, for example. Because we're using Juice, we make a VST 3 version and an audio units version. And if you wanted to, you could even make a version for Pro Tools. So it's really a synth, just like any commercial synth you could buy. You could use it in any host, any DAW. But for this demo, I'm just going to use Audio Plugin Host. So I have a MIDI keyboard here to my side, which you can't see. And if I play the notes on this MIDI keyboard, it goes into this MIDI input block, which is connected to the synthesizer, which is called JX11. And then the synth sends its output to the audio output. And that's really what a synth is. It's something that takes MIDI information, processes it, and then generates sound and sends it to the outputs. The reason there are like multiple outputs here is just to get it to work with Zoom, which is what we're using right now. And if I press some keys, you should hear some sound. So we had some trouble getting this to work earlier, so I hope it still works. I don't know if any of the other people could give me a wave if the sound worked.
Yep, all good.
Oh, all right, excellent. So I want to talk a little bit about this synth, so I can open it up. This is the user interface, which is not very pretty. This is what you get in Juice when you don't provide an actual user interface. It's automatically generated. On the left here are all the parameter names, and for each parameter, there's like a slider control that you can use to set the parameter. And this synthesizer is a so-called virtual analog synth or a subtractive synth, which means it has an oscillator, which creates a sound. The sound then goes through a filter, which is used to modify the sound. And then there's a bunch of other things along the way as well, but that's really the basic idea. We start with a sawtooth wave, which what you just heard, which is what this sounds like. And then that goes through a filter, and then we can use that to shape the sound to make it into something more interesting. Now, this particular synth is not something that I wrote myself. I found this on the internet. It comes from a collection of source code that was donated by its author, Paul Kellett. This is the MDA suite of plugins. This was a fairly popular suite of plugins, free plugins around in the early 2000s. And Paul, he donated his stuff as open source. And I thought that's really great because the MDA plugin suite is really nice. It has a lot of stuff in there. And you can really learn a lot from audio programming by studying those plugins, which is what I was doing. And I found that the JX10 synth was really nice because it's not too big and it's not too small. If you want to explain to someone how to build a synth, you don't want to have some huge project with loads of features, because that makes a book that's 1,000 pages and nobody wants to read a huge book like that. But if it's too simple, then it's also not very interesting. But this JX10 synth was really like the perfect mix of features. So I thought that's a great idea. I'm going to figure out how it works, and then I'm going to turn that into a book. So that's what I did. I took that source code, I modernized it. The original code had some bugs, had some issues with it. There were some more modern ways to approach things. So that's what I did, and that's what the synthesizer turned into, JX11. So I'm really thankful to Paul for open sourcing his synthesizer, because it gave me the idea to write a book on how to make synthesizers. And again, I think his synthesizer design is like the perfect set of features that you want to put into a book for beginners. So I think maybe I should just play with the synth a little to give you an idea of what it sounds and what it's capable of. But like I said, the features it has are very similar to analog hardware synths from the 70s and 80s, which means there's two oscillators that work together to make sound, and then the filter filters that sound, and then there's a whole bunch of other features that we can use to modulate the sound to make it more interesting. So what you hear now is just a boring sawtooth wave. And I'm playing a chord, so it's a polyphonic synth, meaning that it can play multiple notes at the same time. It also has a special mono mode, which is also an interesting way to play. It's mostly interesting for playing like lead synth lines and so on, or bass lines. But right now we're using the poly mode, so I'm just playing a 3-note chord here, but it's just one single sawtooth, so it's not a very interesting sound. But I can add in the second oscillator, and now you'll hear that the whole thing sounds a bit lower and richer. And I can tune the second oscillator to be something else. So now we have, again, the two oscillators playing together, but they are at a different relationship to each other. I can just put it up 2 octaves higher. So that's the basic sound generating feature of the synth. There's also a noise oscillator, which is at the bottom. I can add that here as well. And now we'll add some noise to the sound, which if you add a lot of noise, it doesn't sound very interesting, but it can be used for special effects. So once we have the sounds coming out of these oscillators, they can go through a filter. And if I play the same chord again, I can change the filter cutoff point, and you'll hear the sound change. And that's really the basis of a subtractive synthesizer. And all the other features are there to help make this a little more interesting. So for example, I was moving the filter frequency back and forth, but you can also do this automatically using the filter LFO, for example. So an LFO is a low frequency oscillator. It's a typical thing used to modulate sounds. So if I move this slider up, you can hear that it does sort of like a wah-wah effect. And I can change the speed of that with the LFO rate. So that's one way to get a more interesting sound. The other way is to use the filter envelope. An envelope is a way to describe it, how the sound changes over time. And we use a typical ADSR analog envelope in the synth. And there's like two envelopes. There's one just for the amplitude of the sound, which means if I set the attack, for example, then you'll hear the sound fade in. Well, maybe not in this example. And this is a typical way to shape sounds with the envelope, but we can also apply the envelope to the filter. And in fact, it was already active. And if I turn the filter envelope up a little bit, maybe I should just play a single note. It's a little subtle, but you can hear that when the note starts, you can hear the filter value change a little bit. And if I change the filter, let's change the filter decay. Change the filter attack. Maybe change the resonance a bit. You can hear some interesting filter movement at the start of the note, and you can do the same thing at the end of the note, which I'll demonstrate in a little bit. And then, in addition to this, we have I already showed that there's an LFO for the filter. That same LFO can be used to add vibrato to the sound. And if you set up the oscillators in a special way, then it can also do something called pulse width modulation, where the two oscillators combine to make a square wave, and then it changes the width of the pulse. Now, these are all the basic parameters that are in the synth, and together you can use them to make interesting sounds. And so if I open the list of factory presets, then, I mean, I'm not a great sound designer, but some people are, and various people have contributed presets to the original JX10 synth. So I added those same presets into this synth. And I just want to show you a few of these, just so you can get a sense of all the different sounds that the synthesizer can make. Because it looks like a fairly simple synth, you know, just two oscillators and a filter and some envelopes. But that's really all you need to make very interesting sounds already. So for this particular preset, you can hear that when you start playing a note, the filter sort of comes in, and then when I let the note go, the filter also, as the sound fades out, also the filter changes, which is quite an interesting effect. But for a totally different effect, we can try some of the other presets. We also have some lead sounds. I'm not playing the most interesting tunes, but I guess that's, you know, want to avoid copyright infringement. There's also some bass sounds, and this one's interesting because it shows another feature of the synth, which is a glide. So if I play one note, and then I play another note, you can hear that it glides between these notes. And if I set the glide value a bit higher, then it's a lot easier to hear. And, you know, there's like a whole bunch of other presets. I'm not exactly sure how many there are, like 40 or something. Very interesting sounds. quite a wide variety of sounds. So even with these really basic features like these oscillators and just a simple filter, you can already do quite a lot. So I think that's why I thought it was a very interesting synth, because it shows that you only need to implement like a number of simple features like oscillators and filters and stuff, and then you put them all together and you get very interesting effects. Like this echo pad, for example, this preset. It kind of sounds like it has a delay in it already, but there's no delay in the synth. It's just somebody was very clever with how they used the features of the synth to make that sound. I think that's what I wanted to show about the actual synth that we're building. So I will close this, and then I'll pull up the ebook again. And now I just want to go through the table of contents a little bit, just to give you a little bit more information about, you know, what's in the book and in what order and how, you know, how is stuff explained. So I see this book really as a story where we start from not knowing anything, basically, to adding all the pieces of the synth, slowly building out the synth until it's like the complete thing. It's not like we start from nothing and then only something interesting happens by the last chapter. In every chapter, we add new features and make the synth more interesting. So right away, you already start building the synth, and then you start adding the new function. You keep adding functionality to the synth. So you keep building it, you keep growing it. And if you feel like halfway through the book, you've already learned enough and you're ready to go make your own synth, that's great. Yeah, let's just go quickly through the table of contents. So there are 14 chapters in total, but the first 12 chapters are all about audio, the audio processing part of the synth. And then there's a chapter about the user interface, which you saw that the user interface that I just demonstrated wasn't very pretty, but we actually go into building a real user interface for the synth as well. And we'll talk about all the interesting problems that are involved in making user interfaces, but also making your own styles, making your own look and feels, as we call them in Juice, and tricky things like making the audio thread talk to the UI thread and so on. But that's, you know, kind of an advanced topic, which is why it's at the end of the book. The book begins by talking about what a synth really is. And if I go to this chapter, you can see that it talks about these things that I quickly went through just now. We have a sawtooth oscillator, and then we have an envelope to change the sound, and then we filter the sound, and then we add modulations and so on. And we end up building the thing that's shown here in this schematic. This is how all the different pieces fit together. You see all the parameters here and all the building blocks that make up the synth. And we will write all these things from scratch. And I'll explain how each of these things works and how you might even want to approach them differently, for example. So this is essentially an overview of everything that you learn from this book. Yeah, let's quickly go back through the table of contents. So as I said, we use Juice. If you've never used Juice before, that's fine. It's explained completely from the beginning, how to install it, how to set up new projects. Juice is a little strange in how it's set, how you create projects. If you've done C++ before, then using Juice might be a little strange, but it's all explained here. Also, if you don't want to use Juice, this chapter explains how you can still use the book. Then we'll talk about MIDI and digital audio. Now, MIDI is the input to the synthesizer, and it's not necessarily difficult to understand, but it is a little tricky to do right. So that's why there's like 2 chapters dedicated to it. And if you want to make synths, then having a good grasp on MIDI is really a good idea, because everything that goes into your synth is MIDI. So you definitely want to understand how to handle MIDI and how the MIDI protocol works. But also the output of the synth is digital audio. So it's also useful to understand how digital audio works. And so the book explains everything about sample rates and sampling and how all that stuff fits together. And then we'll build the synth. So we start with oscillators. Oscillators are the things that create the initial sound that comes out of the synth. And the simplest oscillator is a sine wave oscillator. So we'll spend quite a bit of time making sure you know how to build sine wave oscillators. Now, the synth itself doesn't really use a sine wave, but it uses a sawtooth wave. But still, that builds on those ideas. And for the LFO that we use for modulation, we do end up using a sine wave. So it's this is a good set of chapters to really work through to understand how to make sound out of nothing, basically. And for the sawtooth, we have another problem, and that is oscillators and basically anything we do in digital audio always has the possibility of creating aliases, which are frequencies that we don't really want, nasty frequencies that create buzzing and so on. And to avoid this, the book uses a technique called blit, which is an older technique, but I still thought it was very interesting to explain it because it allows me to talk about impulses and impulse trains. And these are like fundamental concepts in audio programming. And I thought it's important for a book like this to not just give you a bunch of source code that does certain things, but also to help you understand what are the basic ideas in DSP and audio programming. And, an impulse, that's like the most fundamental signal that we deal with. And the sine wave is the most fundamental kind of waveform that we deal with. So the book does spend some time on those ideas and explains, why would you want to understand these things? And then we just keep on adding things to the synth. We do the envelope, which is also, one of the basic fundamental synthesizer building blocks. We will talk about polyphony and voice management, because if you're playing a single note, then you just have one oscillator or two oscillators and a filter. But if you play 5 notes, then you need 5 times that many oscillators and filters. And how do you manage this in a way that actually makes sense? And I found that getting voice management right in the synth can actually be very complicated. So that's why we dedicate a whole chapter to it. And then we talk about modulation, such as the LFO. We can also do stuff with the modulation wheel on the MIDI controller, or the pitch bend wheel, or any other sliders and stuff. I didn't really demonstrate these features, but the synth does have quite a few modulation options. And that's what that chapter is about. And then we conclude with the filter chapter, which is also, the filter is what makes a subtractive synth like this. So we do spend some time on getting the filter right and also how to modulate the filter. And then finally, I want to quickly go through the user interface chapter, because I didn't really show the user interface of the synth, because we do spend most of the time talking about how to actually get the audio processing done. But it wouldn't really be a complete book if I skipped the user interface, because there are things you need to know about how to interface or how to talk between the audio thread that does all the audio processing and the message thread, or the UI thread that shows the UI on the screen. And so we go into that in the book. It shows you the responsibilities of the different objects in your synthesizer code, and how to make sure you can safely communicate between them. And then we talk a little bit about the user interface. Let's see if I can, there's a thing in the way. See if I can zoom in a little bit. So we do have in this chapter build a custom user interface, and Juice has these rotary knobs or dials that you can to build your user interface, but they look like this, which is not very interesting. So the book also shows how to customize this and to get a user interface that looks more like, where is my picture? That looks more like this. So it's a small change, but you'll have everything in this chapter in order to finalize like a complete custom UI for this synth, or for any other plugin for that matter, because it doesn't, a lot of the things you learn in this book, they apply just as much to building effects plugins as to synths, especially when it comes to user interface. And then we do some other stuff like MIDI learn, where you can assign a knob or a slider on your MIDI controller to features in the synth, and lots of other stuff like this. I mean, the book is packed full with information and handy tips and other stuff. You could probably like read it 4 times and still discover new things. There's also some math. So here's a little bit of math, but I try to keep the math to a minimum because, you know, I have DSP books where page 1, you open it up and they already throw equations at you. I don't really find that very interesting most of the time, but I do like, you know, I do like to jump into the code, but it does make sense that we use some math in order to understand what's actually happening. Because in the end, DSP programming and audio programming, you do need to use some math. You can't really avoid it. So the book doesn't really pretend that there's no math, but it does keep the math to a minimum. Just because I don't think it's super useful to, you know, drown people in math when they're just getting started. So I think, I mean, I'm pretty proud of this book. I think it's a good introduction to, you know, learning how to write your first synthesizer plugin. And yeah, I think that's pretty much what I wanted to share about this book for now. So if there's any questions, I'd be happy to answer them.
Fantastic. Thank you so much, Matthijs. I'm going to bring you back to our main. Actually, I'll keep that up for a little bit, but great. So we have a couple questions, and for anybody who's out there listening and curious about, wants to know more, please feel free to ask questions. In the meantime, I've got a couple here. So Tugrol asks if you implemented polyphony from scratch, or did you use the Juice library to implement polyphony?
Everything related to the synthesizer is implemented from scratch. So Juice does have a synthesizer class that you can use to build synthesizers, but we're not using it at all. And the book does. So the book does in some places refer to these things. So it says in the chapter about polyphony, it says you could also use the Juice thing, but we're not using it. There's also the chapter about the filter. We also use our own filter, but it does give you some instructions if you want to use one of the Juice filters, because Juice has an interesting, like a ladder filter that does sound different from the filter that we're using. And I thought you know, it's useful if you see how to use some of the Juice DSP code in your plugin anyway. So that's just an example of how to use the Juice stuff. But pretty much everything else is just from scratch. And that's not because the Juice stuff is bad or anything. I just wanted to show you how to build it from scratch. Because if you look into the Juice source code, like if you read this book and then you go look at the Juice source code, you'll see like, oh, they do a similar way or they do slightly different. But you'll be able to understand what Juice does then as well.
That's really awesome. Yeah. So if you've been following along with the audio programmer and some of the synth tutorials that I've made in the past, you'll see that I used Juice's built-in synthesizer classes. So you have synthesizer voice, and there's another one, I can't remember it.
Sound, I think.
Yeah, synthesizer sound. That's it. So if you want to know how synthesizers actually work and how to build those classes from scratch and get a little bit more serious about audio programming, this is the book for you. So next question is from Bruno Santos, who asks, what would you say is the best way to follow along with the book? Is there a recommended way that you'd say to follow along?
Well, like I said, it's a story, right? So you start reading it, and then it says, now we're going to install Juice. now we're going to do this, now we're going to do that, now we're going to type in this source code, and this is what that source code does. And then you type in the next bit of source code and it explains what that does and how it fits together. So it's really, maybe I can just show you on my screen here since I'm still sharing it. Let's say, so here we're talking about the sawtooth oscillator, and it shows you, it explains to you what we're going to do, what the sawtooth is, and then it says change the code in oscillator.h to the following, and then you do that, and then you run the plugin, and then you'll see the following thing in your oscilloscope, and then I explain why that works and what the problem is with this and how we can do it better. And then you type in a new bit of source code, and then you run the program again, you play with it, you look at the oscilloscope, you look at the frequency analyzer, and that's how you just follow along. And hopefully every step of the way, if you have questions, they are answered in the next paragraph in the book. I try to write it as a story. If I would explain how to do this to someone like one-on-one, that's probably how you would do it. You say, now let's try this, and then what are the problems with it, and then let's try the next thing, and so on.
Fantastic. Luke O'Dwyer asks, hey, the book looks great. Can I ask how in-depth a programming background would one need to utilize the book? How advanced would you need to know programming concepts as a prerequisite? So,
in theory, you don't need to know any programming, because you essentially you copy paste code from the book. But it's nice to know what's going on when you do that. Like this is what I just showed here. Change the code in this file to the following. It's nice if you understand what a class is and what these things here are, and what a method is, and so on. I mean, that's like super basic, but if you have no idea what this code says, then it's also kind of pointless to be writing it, because you have no idea what you're doing. And you might as well just, go to the GitHub, download the full project and run that, rather than just copy pasting if you don't know what's going on. However, if you only have like basic programming skills, it's still fine, because it's not going to be much more complicated than the source code I've shown here. Most of the source code that's used is very straightforward. There's no fancy stuff. Like C++ code can be as complicated as you want to be, but I've tried to keep it as simple as I could, without any fancy features or things that require, you don't have to be like a 10-year programming veteran to make sense of it or anything. But one thing I want to say is that if you don't have a lot of programming experience and you make a mistake, you can get really strange error messages that don't make any sense to you. So for example, here, this source code on the screen, it ends in a semicolon. If you forget that semicolon, for example, or if you forget one of these braces, you can get really strange errors and you have no idea how to fix them, because the compiler messages won't make any sense to you. So that's the problem. If you don't have a lot of experience, then if you make a mistake, it can be very hard to figure out how to fix it. However, we do have Discord, and if you buy the book, there's a private Discord channel that you can join, and I'm there most of the time. So if you run into any of these strange errors and you have no idea how to fix it or where it comes from, just ping me, ask the question there, and I can probably help you on the way. So I don't want to scare you off if you don't have any programming experience and you really want to learn how to make synths. I mean, just give it a try and ask for help if you get stuck.
Yeah. And another thing is there are some great resources if you're looking to learn C++ and the basic concepts. There's a channel called The Cherno, which is fantastic for learning C++ concepts, given from a game developer who used to work at Electronic Arts. I also have some basic C++ tutorials where I actually taught my son, who was 16 or 17 at the time, basic C++ fundamentals. So there are a couple good resources out there if you're looking to learn some of those fundamentals while you're working alongside the book. So we have another question from Carmelo, who says, would you say that the way that you implemented the core algorithms is quote unquote better than the ones used by the Juice library? Or did you decide to implement them from scratch just for educational reasons?
Both. And I don't want to diss the Juice library because a lot of the DSP code they have is pretty good. But like this Juice synthesizer class, for example, I wouldn't call that great code, right? It's something you can use to quickly throw something together. But if you want to build a synthesizer that's more than like, I mean, I think they made it to make it easy to create samplers or rumplers, you know, where you just you press a key and it plays a sample. But for more advanced synthesizers, I don't think that Juice synthesizer class is really sufficient. And usually when people ask on the Discord, we say, you know, just write it yourself. It's a lot easier than trying to hack that synthesizer class into doing what you want. But everything else, I mean, the main reason is educational and to make the book not super dependent on Juice, because I know not everybody wants to use Juice or can use Juice. And I think Juice is awesome. You know, I would use Juice for everything. But I also didn't want to make the book super dependent on Juice. And it's just more interesting to learn something like a filter. How is a filter implemented? Rather than just instantiating a Juice class, just write the code yourself and see if it makes any sense.
Absolutely. Great. So I think that is all of the questions. So I'll bring us back to the, oh, here we have a question from Bruno. Imagining a scenario where in the future I release a synth of my own, how careful do I need to be when it comes to using lines of code or methods of ways from your book or even other books? Great question, Bruno.
That is a great question. So, like I said, I did not write the synth myself. I took it and changed the code. It's like the code's completely different now. But I could only do this because the original synth was licensed as MIT licensed. So it's open source, MIT licensed. And the source code from the book is also MIT licensed. And basically that means you can do with it whatever you want. Just, you know, if it breaks something, you can't sue us, and it would be nice if we get credit. But to be honest, for educational materials like this, you can just use the code. You know, the whole point is to teach you how to do stuff and to give you tools so you can build your own products and your own things. So it would be kind of silly if we would say, oh, you need to buy a license for the code or something. I mean, there are books that do that. Numerical recipes in C++, or in C, that's a book that's well known for showing you the code, but you actually have to license the code if you want to use it for anything. But audio programming books, I've never heard of anyone being difficult about the code. So by all means, go ahead and use everything you need.
Fantastic. Looks like that's all the questions. Once again, thank you, Matthijs. Very appreciative of this collaboration that we have together. Thank you for this is a great body of work that would have taken many months to write. So I hope that anybody who's looking at this book really understands the depth of work that's needed to actually put something like this together. So thank you very much for sharing this with the world.
Well, you're welcome. Thanks for having me.
Yes. Great. Thank you. Great. So with that, we will just go ahead and jump into our second talk. So we have the AV8 audio team, Shane Nolan and Steve Lascos. So a few months ago, they shared this really amazing ecosystem that they've created where you can actually write your own DSP and put it on hardware. So many people ask us, how can I create my own guitar pedal? How can I create my own hardware effect? And so AV8 Audio have created this pedal called the Multiverse pedal, where you can actually create, write your own DSP and actually put it on the pedal. So if you're a guitar player, as we see, we have a couple guitar players here in our meetup, then you can actually write your own DSP algorithms and put them on that guitar pedal and take it out to your performance that night. And so they're going to show us how you can do that. And they've also been very kind to have given us a discount code for the pedal itself. So if this looks really interesting to you and you want to start getting involved in this, there's a product code in the description, in the video description. And with that, I will go ahead and pass it over to the AV8 audio team. Take it away, Shane and Steve.
Thanks, Josh. Really appreciate you having us. I'm Shane. We are based out of New York. Steve Lascos is the principal designer behind Multiverse and also the founder of Blackadder Audio. He's going to be giving the presentation about the ins and outs of the platform and sharing his years of experience in doing this. So Steve, thanks for presenting. Afterwards, we're going to be giving a sound demo from the pedal.
Awesome. Thanks, Shane. I'll start sharing my screen here. Okay, can everyone see the presentation slide?
Yes.
Awesome, great. Okay, thank you. So let's get started. Yeah, so we'll be talking about developing plugins for the Multiverse platform. So very, very quick intro about Shane and I. So my name's Steve Lascos. I'm from Canada. I've spent about 20 years working in the DSP industry, designing both hardware and software. I run Blackadder Audio, where I do hardware and software development. I'm a juice programmer. I'm also the maker of the TGA Pro. We already heard from Shane. Maybe he can cut in real quick, just a moment to just kind of introduce himself with the context of the slide and say what that amazing picture is before I move on.
So we make fun audio products for musicians. We're going to be talking about Multiverse, but if you go on our website, you'll also see we have other products like AirPatch, which is a wireless effects controller. A lot of our products are designed to elevate the live guitar playing experience. Multiverse is also a good platform for synthesizers and bass. So if you're interested in checking out AV8 Audio and the types of products, you can go to our website or find our content on Instagram and YouTube.
Awesome. Thanks, Shane. So in this presentation, so I'll give a little bit of background first on, what this is about. And I kind of look at it as like it's the quest for plug-in capable stomp boxes. And we'll talk about some of the challenges about that. I'll go through how you actually develop plugins for Multiverse. We'll do like a very quick high-level overview. And then certainly saving for the end, the really fun part, Shane's going to actually show off, once you've created these effects, what is the user experience like? Whether that's you or whether it's the users of your plugin, because obviously that's where the rubber hits the road. So, I kind of look at this from, I want to be able to create plugins, not just for the studio, but for the stage. So the amazing thing about the plugin environment and the community is the variety of plugins. So how do I get those from, my laptop to my pedal board? So one approach is I could ruggedize my laptop. In fact, this is a picture of my actual rig that I built about 7 or 8 years ago. And I just took a Windows laptop and I mounted it in a case, and it's exactly what it looks like. It's a Windows laptop in a case on a shelf. And on the right-hand side, you can see the blue USB audio interface. And yeah, it works. But we all know that, Windows is not designed to be an audio development environment first, certainly not for performances. So when you're using something like Windows for any type of critical live performance, there is always a risk. While there's things you can do to, get Windows to be more reliable for real-time audio performance, obviously that's not what Windows was created for. So is there a rugged, GID-capable hardware platform that can run plugins? So before we look at that, we kind of need to understand some of the obstacles to achieving that goal. So when we're talking about plugins, the nice thing about a plugin is the developer can write their code and compile it, and then, send it across to somebody who's got a plugin host, which has already been compiled, and that host can run your plugin code. In order to do that, without getting too deep into how, software works, you tend to need things like virtual memory. So you're usually needing like an operating system, or at least the very advanced loader and file system to have something that actually takes in plugins that are made by other people. Another challenge or obstacle is often when you start looking at these embedded devices, these platforms tend to use very specialized DSP chips to get a lot of performance. If you're not familiar with these types of chips, they're really powerful, but they're also very difficult to program for. They require quite a bit of expertise to use effectively, and this can really make them inaccessible for most plugin developers, especially if they're used to writing plugins for an x86, Windows or Mac platform. And third thing is licensing. It's interesting because this came up in the previous talk about licensing. So if you're the platform manufacturer, selling a commercial product that Windows is pre-installed in has a whole bunch of potential legal issues in terms of whether you're allowed to pre-install it, distribution, are you violating Microsoft's user license agreement? So packaging Windows in a product is somewhat of a bit of a minefield. So a lot of the solutions out there that do have a plugin environment on these platforms, they tend to be embedded Linux based. But one of the downsides with Linux, as great as it is when you look at Linux audio, a lot of the licenses, a lot of the libraries you're dealing with are using non-permissive licenses. Earlier in the first talk, we talked about the MIT license, which is very permissive, which is great for people who want to be able to extend that work commercially. And GPL is an example where that can become more tricky. The risk is that you might be required to release your source code, which you might not be wanting to do if you're attempting to commercialize your plugin. So kind of sum that up. What are we looking for? Or what am I looking for? What I kind of want, and I want to have my cake and eat it too. I want something where the user experience feels like a nice modern plugin host. I want it to be an open platform, which means all developers are welcome. A lot of the hardware platforms out there for live use, they're closed, which means only the manufacturer gets to write software for it. And I'd like it to be secure. I mean, if I'm putting my product on it, there should be some level of security to make sure that the work that I do is not going to be easily, copied. I'd like the option of it to be closed source. I mean, lots of people do publish their source code, but especially if you're looking to potentially commercialize, you certainly want the option to not publish your source code if you don't want to, which means you compile your plugin and then, it gets uploaded or it gets sent to the, to the plugin store. I don't need to share my source code. Again, I'd like to avoid exotic DSP. I'd like it to be easy to program. So, typical type CPU stuff. It would be great if it was hard real-time and designed from audio as its primary purpose, not adapted for real-time audio, but designed for real-time audio. And affordable would be great. Admittedly, that's very subjective. There's some amazing hardware out there for doing digital DSP. And it can cost thousands of dollars. Everyone has different levels of cost that is appropriate for what they're trying to do. So I realize that's subjective, but obviously, something a little more accessible than a couple $1,000s would be great. So what really is out there? So we do have bare metal multi-effects units. So by bare metal, I mean they're not running operating systems designed for other purpose. They're made for audio first and foremost, but they are closed platforms. So that the typical ones you might think of, only the manufacturer gets to write the effects. You don't get to do that. The open platforms, as we discussed, they do tend to be Linux based. They use a lot of different libraries with many different licenses, which can really be a quagmire. And even if it is an open platform in general, like the desktop plugin environment we're familiar with, security generally is on the responsibility of the developer. So if you do want to have some type of product key or security or whatever in your plugin, you need to decide, what that's going to be and how you're going to implement that yourself. So, okay, let's get to what we're here today. So we're talking about the multiverse. So the multiverse is an open platform. It's open to any developer. We want other people to develop plugins for this hardware the same way you would for the desktop or laptop environment. It is closed source, so developers don't need to provide anyone their source code, not even us. Licensing, it is commercial friendly. So most of the intellectual property, the software that goes into making Multiverse happen, it was all written by us. Any open source that is used is all permissive. So it's very commercial friendly licensing. You won't have any of those licensing restrictions getting passed on to you as a developer. And it is pure bare metal. So there is no S. It's pure bare metal programming. So it's purpose designed for real-time audio. And because of this, we do get really exceptional DSP performance for very moderate, low-cost hardware, which really makes it accessible. And I did mention security. So the security on this is implemented by the hardware. So similar to the way security works on a game console, or your cell phone. If you're a software developer, the platform handles, purchase versus free software. You don't need to go and implement your own product keying yourself. It's handled by the platform. Okay, so all right, how do I program for this thing? So one of the things that is kind of key to understanding Multiverse is understanding Teensy audio. So if you haven't heard of Teensy before, Teensy kind of took Arduino. So if you're a programmer, you might have heard of Arduino before, which is famous for being very user-friendly, very beginner accessible, with some IDE tools that take a lot of the complexity out of just trying to build software. And Teensy kind of took that and combined it with high-performance DSP-based microcontrollers to really open up a lot more compute capability. And they combined it with an audio API to make it easy for people to get into audio programming. Multiverse, we decided we're going to leverage that really simple Teensy programming API because of how powerful and simple it was. And then we stick an even more powerful backend on it so that it can become more than just a simple maker playground and become something that's a full-fledged plugin ecosystem. So quick review of some of the Teensy audio basics. So Teensy, they really kind of smashed the barriers to entry to get into audio programming. Part of that is when you make your audio classes, they have a base class that you inherit that has some very simple functions. But most important, if you get into embedded audio, a lot of the complexity comes with having to talk to the audio codec, doing DMA memory transfers, doing this in real time. So they abstracted all of that away. And all you as the developer need is to know this one class called audio stream. And in the back end, Teensy provides like a static pool of audio buffers and performs the routing for you. So the parts that we need to know for Multiverse that we've reused from this API, and it's really almost everything you need to know from the Teensy API is on the screen right there. There's just a host of functions. So we've got, given that there's this static pool of audio buffers, you want to be able to allocate, request a buffer from the pool to work with. You want to be able to release it back to the pool when you're done. The receive functions let you basically request your next block of audio for your algorithm to start processing. And of course, when you're done processing that block, you want to transmit it. So those are the basic functions. The last one, which is the most important one, is this function called update. This is the equivalent of the process block function if you're already familiar with Juice. This is the function you override, and then what you implement in this function is your audio algorithm. So when you're programming, really writing the update function is where you spend the vast majority of your time. You don't spend your time writing a lot of glue logic. You don't spend your time writing GUIs, and we'll see in a moment why that's the case. So if you want to create a Teensy audio effect, the gist of it is you can see this simple example here on the right, but you're going to create your class for your audio effect. You inherit the audio stream. And you're going to, in your update function, you're going to, ask for the next block of audio. In this case, it's receive writable. You can either do vector processing or step through one sample at a time to do your processing, whatever that is. You transmit it and you release it. And it's really simple. So if you're someone who's thinking about getting in audio programming, this is a really, really great way to create a functional audio effect without having to learn a ton of infrastructure about the framework you're using first. So we extend that a little bit when we make a multiverse plugin. So our multiverse plugins, we call them an EFX. So we inherit that audio stream you just saw. We add another one called the audio effect wrapper, which lets it talk to the multiverse backend. We still use the audio block type that Teensy audio uses. We still use the update function for audio processing. One change that we add is all of your config parameters for your audio effect. They are generally mapped into a range of 0 to 1 by the back end. And inside your programming code, you can call a function to get that converted into whatever range you want. So when we get to the effect creator tool in a moment, we'll see how that works. The other thing is all of this code that you actually see here gets auto-generated by the tools. So when we step through the example, the glue logic that is required is generated for you. You pretty much just kind of step in and mostly just start writing your update function. You don't spend much time really doing anything other than writing the code that implements your audio algorithm. So the effect creator tool, which I'm going to be doing a live demo in just a moment, is kind of the heart of how you create these EFX plugins. It is a what you see is what you get editor for creating the user interface. So rather than coding the user interface, you just use a simple graphic editor to build the GUI that you want. This tool, as I said, it generates all the boilerplate code that you need to interface with the Multiverse framework backend, and it will build, like literally compile and build and package up your plugin for you. So just to review the steps of what we're going to see when I do this live demo is, because this is really your flow, is your workflow. Step one, you're going to enter basic info. So metadata, basically, what's the name of my company? What's the name of my effect? How many input output audio channels will it have? I can optionally add my own graphics to make the user interface, look a lot more creative and interesting, but that's optional. I don't have to do it. You can still use just standard arrays of effects that get generated for you. Step two is you're going to specify all the parameters you need. So for each control that your audio effect needs, you might have switches, you could have selection encoders, you could have just continuous variable parameters like a pot, specifying the range and the default values for them. Step three is once you've done that, you're just going to kind of hit the generate button, and it will create all of the C++ code for you that you need to make your effect interface into the back end. And of course, step four is building your effect to get your compiled binary and be ready to run in the host. So let's actually do that. Let's take a look through the effect creator tool right now. So I'm going to shut down my thing there, and let's go and take a look at the effect creator. So you should be able to see the effect creator tool. Thank you, Shane. So I'm going to go and just reset this. The default settings is actually a workable effect right out of the box. So the first thing you can do is build something that actually runs on the hardware, which means as you start to build your effect, you're always starting from a place of a working project. So this default project that comes up is a pretty boring one, but it illustrates everything you need pretty good. So this is a volume pedal. So I'm just going to go and save this as a new project into a folder here. All right, and let's go take a quick look at what that actually did. So it just created a folder called Multiverse Community Volume Effect, because those were the default values. And inside I've got some folders, and it's got my project file and some folders for any graphics I add and source code. So let's actually go and see what that is going to look like and walk through this tool. So the section in the top left corner is where you provide, the metadata about your effect. So you can see things like the effect name, the developer company, descriptions, things like that, the name that you want your audio effect class to have. The number of audio inputs and outputs is pretty important. You might notice as I'm scrolling around here, there's automatic tooltips that pop up to tell you what they are. You can optionally provide a company logo if you want. If you don't, it usually just shows a Multiverse community. It'll also have a default little pedal icon for arranging on your pedal boards. And if you optionally want, you can create much more advanced graphical art. I'm not going to do that here because I want to kind of focus on the basics of the programming. Moving on, these two gray boxes below is the area where you define your controls. So there's two default controls that are always provided and are mandatory. One of them is a bypass control, and one of them is a volume control. So each control gets one of these little boxes. You can specify the type of the control, you can specify the range, and you can specify graphics. So just for illustrative purposes, let's go and add a new control just so you can see how that works. So I'm going to click the add button at the top, and let's say we wanted to create our volume pedal is now a tone pedal. So it's going to have a low pass filter. So I'll call this effect is low pass filter. I'll give it a short name, just LP. And my description will be sets the cutoff frequency for the low pass filter. This is probably going to be a pot, so it's a linear control. Now, since this is a low pass filter, rather than just using generic, 0 to 1 or 0 to 10, I mean, we can use more meaningful units. If this is in hertz, In fact, I'll even put hertz. Oop, I'll put hertz there. So let's just say we wanted our low pass filter. We know in our audio algorithm, it's going to go from 200 hertz to say 10,000 hertz. And there we go. All right, so we've added a new control. And you might have noticed when I added that, a new control popped up over here. So in addition to our volume and our bypass control, there's now a low pass filter. And we can see that it actually goes from, 10K to 200. So it can range in whatever units we want. So different controls might have different numbers or values or ranges that just make much more sense. All right, I'm going to save my project. And now you remember the step 3. So we already completed the first 2 steps, which was, name your, you'd set up your pedal, you add your controls. Step 3 was generate the code. So there's a generate button here at the top. So I'll click that. And it's actually switched my view from the previous graphical array view to the source code listing. So it's created a public header file and a couple private source files. You can view them in the editor, but I'm just going to actually go to a nice one here. I'll pop over to my VS Code session and let's take a look at that. So this was our project it created. So in the public header file, it created a file called volume effect because that was our name. So this is all the automatically generated code. So I'm not going to go through everything in detail, but some key things you might notice is it created some automatic enumerations for our controls. There's our low pass filter. It knows how many audio inputs and outputs we assigned. It was 1 and 1. And the rest of this is just your basic boilerplate code. You don't really need to worry too much about it. As you create a real effect, you're probably going to want to start adding and customizing this a bit. So you'll notice if you've worked with the Juice Producer before, when you use it to create template files, similar to that, you'll have these comments that are basically guards where you put, as long as you put your custom code between the guards, if you need to change your controls in the effect creator and regenerate them, anything between the guards is protected. Anything outside the guards gets automatically regenerated by the program. So that's the header file. Let's take a look at the source implementation file. So the volume effect CPP file has a bunch of boilerplate code. It's created our default effect. It's created a constructor and destructor. Whether if you need to do anything in there, you're free to do it. And it's even created a baseline update function. So inside this update function is what happens when you process a block of audio. So I'm going over this pretty quickly. If someone's got more detailed questions, we can certainly address it in the Q&A. But basically, there's a little bit of pre-processing you always do. You grab an audio block. There's a built-in function that checks to see whether you're bypassed or not, whether the audio is valid, etc. And if for any reason you shouldn't be processing this audio, you can return. There's a function here that is basically measures your RMS. When Shane gives you the demo, you'll notice that the plugin interface has the RMS input and output levels for each effect. So there's a little call you make there. And then if we jump down to the bottom, we can see that there's a call to measure the output RMS. And going back to that Teensy Audio API, we transmit our block and we release it when we're done. So the pattern is grab your audio, measure the input, do your processing, update your output RMS, transmit your audio, and release it. So inside this for loop is where you would begin to replace this code with what your actual algorithm is going to do. And we'll take a look in just a moment at some more advanced ones, but this is actually a working loop. You might recall that we started with just a volume pedal, and it's just going and doing a floating point multiply of the input sample by the volume control. So you could build this and run it immediately. And as I said, use that as your starting point. It also created processing functions based on your control. So by default, it always creates a nice volume one and demonstrates a nice built-in convenience function for doing volume in dB. But what's more interesting is the fact that it automatically wrote this function for the low pass filter. So the back end, when Shane shows you these effects working in the plugin host, anytime the user modifies the low pass filter control, this function is going to get called by the back end. And you can see that by default, it's just assigned the internal variable to value. But remember, I set that to 200 hertz to 10,000 hertz. And I also mentioned that the backend assumes all values are in the range 0 to 1. So we probably want to get that back into our user value, and it automatically created a function for us to do that. So if we skip over to this base file, this one you don't write the code for at all. It's automatically generated. And the one that's interesting here is the get user parameter value. And it has taken the ranges that were in the effect creator GUI, and it automatically can convert those normalized 0 to 1 values back to the user one. So you can see here it's doing the math to convert the 0 to 1 range back to the 200 hertz to 10,000. So we would probably want to use that. So I'll just pop back over here for illustration purposes. And what I would probably do is I would replace this with this function. Now, if we take a look at it one more time, it wants you to indicate which parameter you want to process and what the value was. In our header file, it had created these enums. So that's the parameter index I'm looking for. I'm just going to grab my low pass filter and I'm going to paste that in there. And I'm going to call the value. And so what this is doing is this will make sure that anytime the user changes the low pass filter value, what gets stored in my plugin is the value in the base that I defined, which was 200 hertz to 10,000 hertz. And then I would go and implement my tone filter up in the processor. So this is a really simple example to show, kind of demonstrate a lot of the stitching code either is not what you need to worry about, or if it is, it's automatically generated for you. So if we pop back to our, save that, pop back to our program. And at this point, we're on step 4, we build. So we click the build button and there we go, it passed. So it has actually created the plugin. If I pop over to the folder here in the binary folder, that is my plugin file. I'm done. I'm ready to use this in my Multiverse host. And at that point, it's done. You might be kind of curious, well, what happens? It's nice when things work, but what happens if things don't compile? We mentioned earlier, for people that are new to C++, forgetting a semicolon is something you might commonly do. So I don't expect this to work this time because I took the semicolon away. I click build. Yeah, so it failed and it's complaining, I expected a semicolon on that line, etc. So, that was obviously, we wanted that semicolon there. Okay, so that's a really quick overview of the effect creator tool, but that's really all it is. It's basically using this tool to design your effect, and then you jump into your source code and you program your audio block as you would like. This was a very simple example. What does a more complicated example look like? So I've got 2 to show you. One of them is my Blackadder tremolo. So we can see there's a few more controls here. We've got bypass, we've got the LFO waveform selector, rate and depth of the LFO. So we've got lots of controls. And in this one, I did use the custom effects. So how did I get this? Well, the GUI is created by specifying the size and the position of each control. So the bypass control, which is this knob here, and by the way, this is functional, you can play with it. If I start changing the position, for example, here, you'll start seeing it move down on the pedal. So it's literally what you see is what you get type of editor. In terms of graphic files, what I had to add to create that was, if I just take a look at some of the graphics that I used. So there was my logo. This is the graphics for the waveform encoder. This long one that you can't see was actually all the positions of the pots. This is my on and off button with the LED built in. And all of these came from free online resources. There's a great website called Web Knobman that lets you create those and customize them, even if you're not a graphic design artist, which I am not. And one more example to kind of show a really cool feature for people who are Juice developers. Another great effect is the Chow Centaur by Jatin Chowdhury of Chow DSP. So he's created a clone here. He does a lot of his effects using Juice, and he wanted to start porting them to the Multiverse, and a lot of his plugins used Juice modules. So while this is not a Juice plugin per se, you can reuse Juice modules if that's what your plugins are based on. So if I go to the source code view and call up the settings, there's an option here to show some Juice modules. And also, this one also required some define statements. So this is where you would do that. And so it's added down here in addition to my header files and my private source files. I now have this option of adding juice modules, and all these here are Jaquin taking advantage of a lot of juice modules that he wrote for his juice compiled plugins. Okay, that is the effect creator. I realize that was a very quick overview, but I wanted to make sure we have time for Shane to show us what's going on. So that was that demo. So to finish up my part, just some quick details. So the hardware, what is it? For those who follow these types of things, it's a Cortex M7, 600 megahertz. It has a floating point unit, stereo codec, lots of assignable switches, encoders, expression, MIDI input, all that type of stuff. It's got some external RAM for audio buffering for things like delays. If you're a programmer, in Effect Creator, we use C++17. We support juice style modules. And if you're familiar with the CMSys math DSP library, you can use that, though we're finding that the compiler now, the compiler optimizations are so good, you kind of just write regular C++ code. These previously made libraries don't actually add any acceleration. And in the designer, which Shane's going to show in a moment, this tool is what you actually use to take all those plugins and build virtual pedal boards as presets, and go from there. So with that, I'm going to turn it over to Shane now, and he's going to show where the magic happens once you've got all of these wonderful EFX plugins at your disposal.
Thanks, Steve. And yeah, your presentation got me very excited to show this off. I definitely learned a lot. Here's the pedal that I'm using, by the way. So I've plugged in live with the Multiverse pedal right now, and I'm going to be showing you sort of the end user experience, whether you're making your own or sharing them online. This is what it looks like to use the pedal. So let me just take a second to share my screen. Okay, so this is the plugin host. It's called Multiverse Designer. This is your experience where you get to design your own pedal boards, play with your effects. At the top, you have a view that represents the hardware. It's got the 4 knobs and 2 buttons, just like on the real pedal. All the controls are fully assignable, so that's what that view is for. On the right, we have the library of effects. So you can scroll through here, and I'm going to be building a basic pedal board from scratch to show you how that works. Finally, the main view is the virtual pedal board. We drag and drop to make connections, and also it supports stereo routing. So if your effect is stereo, that's where you do your stereo routing. So I've just pressed the button up at the top. This is the preset list of my boards. I'm going to make a new one to show you what that looks like. First, you start with your name. So I'll just call it board. Rather, make a new board. Okay, so blank slate starts with an empty board. I'm going to drop my input and my output and then begin adding effects. First, I want to start with a distortion. So I'll go to the distortion selection in my library, drag and drop the first pedal. Now I'll go back to all. I'm going to add a couple more effects. Steve has a really great delay pedal from Blackadder Audio, so I'm going to drag that in, and I'll make one more space and add a reverb. So that's the simple mechanics of making an effect signal chain. So each one of these, you can right click it, open up the full art view. And that is sort of like what you see when you're building this in the creator software. Now to complete the pedal experience, I'm going to assign control. So I'll right click my stomp switch and I'll assign it to the stomp switch on the pedal. I want the LED to light up. So I'll drag and drop this to the LED. This effect has a boost, so I'll add the boost and I'll add it to the pressable encoder. Each encoder has a switch built in, so that gets a little bit more extra useful. Also, it has another switch, so I'll put that here, and I can just drag and drop to assign my drive, tone controls, my level knob. All right, so now I've assigned controls to the Multiverse pedal, and that's a really fun example of a basic board. I'm going to switch over to a video to quickly show what that sounds like. and make sure that my Zoom audio is working. Okay. So in this demo, you're going to hear the board that I just made and also see how the hardware controls interact in real time with the Multiverse designer. When I press controls on the pedal, the interaction takes place in the software, and they both sync up in real time. So each effect also has a as an all view, where you can see even more effect parameters. If you're a developer and you ran out of space and you want to keep it like a nice clean looking pedal, but you want to include more effects controls, this pedal has 3 extra options that you get when you open this up for the boost clip sounds. So I'm going to leave the video for now and go back to my live designer view. Here's another example of a multiverse preset. This one has 6 effects. It starts with a compressor by Transmogrifox. It's got the same distortion, phaser effect, delay. I wanted to show this one because we're using stereo routing. So this effect utilizes the spatial enhancer effect, where you can split your audio signal from mono into stereo. And then this reverb, which has a stereo output as well, gives a really nice wide sound. I'll pick up the guitar real quick and see how that sounds. So a fun rhythm guitar tone with a little bit of ambient characteristics. I'm going to open up a couple of the effects and show the views here. So increasing the delay time. I'm going to go through the video to give that tone example where we see some of the more effects in action. So I'm changing up knobs, I'm turning my effects on and off. That chorus has a really cool knob, by the way, where the glow grows when you change the effect. I'm using the same. Here's another example from the same preset, this rhythm guitar preset. This time I opened up the EQ and the Blackadder tremolo effect. We're gonna turn on the EQ to get a bass boost. So we're showing the 5-way selector where you can choose your waveform from the Blackadder tremolo. Each effect has the monitoring that Steve mentioned up in the upper left, where the green and yellow bars show you the real-time volume levels. And then here's just a more extreme example of the reverb. Okay, one more preset that I had prepared to show you. This one's the lead guitar sound. So the first one we were looking at is this ambient guitar sound. It's got the EQ, the chorus, the tremolo. I was actually showing this one first by accident, but yes, this is the one with the compressor, the drive, the phaser. This is going to be the lead guitar sound. So here's the tone example for that. So that's the end of the video. I'm really stoked to be showing this off. We've got a really nice library of effects by a variety of creators. People who created these effects, joined the Multiverse community, picked up one of the pedals and started making their own effects. So these ones are available for download on our website. Many of them are free and included with the pedal, but also some of them are not. Some of them the developer chooses their own price. So that's why we have security, so that developers can actually monetize or commercialize their effects. So when you go to the Aviate Audio website, here's the downloads available that you can then open up in your Aviate Audio designer software and start using with the pedal. For you developers, we actually just came out with something new on the download section of our website. We have a pedal graphics library now. So if you're in the creator tools, this gives you a little bit of an overview about how to make the UX for your pedal. And you can just choose in one of these free graphics that we provided. We also have templates for your pedal that you can add your background to, your own information, or you could use one of the stylized ones. So I just wanted to make sure that, every step of the way, we're making it as easy as possible for people to create their own effects on the pedal. Steve, is there anything else you want to see from our effects?
Yeah, one thing I actually didn't mention during my bit is if you can call up the Chow DSP just a moment for the graphics.
Yeah, which one?
The Chow Centaur. So if you call that one up. So just to kind of highlight for people that are a little more into DSP, so this is a great effect, as I mentioned, by Jaquin of Chow DSP. It's using wave digital filtering, which is a pretty advanced circuit modeling technique. When you run this effect in isolation, it uses about 10% of the CPU, which I was astonished by, not only that the hardware is capable of doing that, but also the skill that Jaquin applied in developing his wave digital filter library. And then Shane, if you actually can bring up the fuzz machine. So one thing we kind of got to celebrate recently is Jaquin also published the fuzz machine, which is the first ever neural network effect running on the hardware. And so, as you can expect, a neural network would take more compute capability, but even in the moderately powered hardware that we're providing to make sure that it's cost effective, you can still run neural network models. And I think that fuzz machine uses up about 4%. All the other effects that Shane demoed, I did have a slide with the numbers, but you probably didn't want to necessarily read more slides. But all the other effects use anywhere from about 2 or 3%, maybe 5%.
Here's an example. We've got this one uses 16%. It's got 3 effects. This ambient rock preset has 5 and it uses 21%. And then this leads preset, which has delay and reverb and distortion, this one uses 37%. And then, by the way, since you shouted out the fuzz machine, There's that sound.
Yeah, so we've been very pleased with the level of performance that the developers have been managing to get on the hardware, to make it really, really versatile, even beyond what our hopes and expectations were.
So here's another sound demo from the same preset. By the way, this view you can zoom in and out to navigate your board to make it easier to see everything. And the
Awesome.
delay has lots of...
That's awesome, Shane. Thank you. I think, are we ready for some Q&A, Shane?
Oh, most definitely. I hope there's some questions.
Yeah, there are a couple questions. So one of those, I think you've may have answered pretty effectively. So you had mentioned wave digital filters and some of the more power intensive types of algorithms. George has asked, have you done any analog simulations? Because he recalls that the Moog ladder filter takes a sizable amount of TNC power. Have you done anything with analog simulations? And what have your results been?
Yeah, so I think pretty much most the nonlinear effects are doing analog modeling. So certainly Jutton's Chow Centaur, the Klon one, is using wave digital filters to do the analog circuit modeling, and it was using a neural network to do the analog circuit modeling for the fuzz machine. And the distortion, the dual overdrive, that black overdrive that Shane was doing, Transmogrifoct was literally using, I believe, tube modeling for that one. As far as the specific the ladder filters, that I don't know. I don't know whether any of our developers have personally tried to implement that yet, but we're pretty happy that nothing should really be completely off limits within reason on the hardware.
Also, I believe your analog delay.
Yeah, the analog delay does modeling of a BBD, like bucket brigade delay style delay. So basically, that one's mostly more modeling the filtering tones that you get with those degradations on the BBD.
Awesome. So GemX asks a couple questions just regarding the specification of the pedal itself. Says what are the latency numbers, bit rate, and kilohertz quality of the pedal and dynamic range of the AD and DA?
Some of those I know off the top of my head. Some of them, if we might need to go look them up and post them in the Discord. So the codec is 48 kilohertz. Most of the nonlinear effects that people write, they just do internal upsampling. So the 48 kilohertz is what goes in and out of the codec, but you can upsample to whatever you need internally, and that's exactly what most of the distortion effects do. The latency is around 6.5 milliseconds end to end, if I'm not mistaken, and that won't depend on how many effects you run. It's pretty much always 6.5 milliseconds. And the specs on the ADC DAC, I think I'd have to go look that up.
What about the input gain range?
Oh yeah, so the input, so depending on, we wanted it to be versatile for multiple instruments. So if you're plugging a line in, or you're taking like if you're using a line out device like a keyboard or something, or synth, or you are using the effects loop from an amp, sometimes you actually don't need gain, you need attenuation. If you've gone through like a 9-volt pedal and a high gain 9-volt pedal in front of this, you actually need attenuation. So it has about minus 30, I can't remember exactly, minus 30, 32, 36 dB of attenuation and plus 24 dB of potential gain. So the idea there is that you've got plenty of attenuation and gain on tap, so that if you've got a guitar with very vintage style pickups, you've got all the gain you need. And if you're putting in hot active pickups, another pedal or a line level device, you can also make sure you're not overdriving the inputs.
Great. And one more question from myself. Can you tell people about the offer again for the Multiverse pedal and the discount code?
Yeah, thank you. So the Multiverse pedal comes with all the software that you saw, and we're running a special discount. It's the best discount we've been able to offer yet to a community, so that's why we're keeping it limited. And I'm not announcing the amount on the stream. It's just it's in the Discord though, or you could just follow the link and use the code to find out. But it's Tap Meetup. You can use it on av8audio.com. Gets you a nice discount on the hardware, and also all the development tools you need, our support to help you bring your plugins to life on a pedal. So think about us if you want to try creating an audio effect for a guitar pedal. This is a really fun way to do it. Our whole goal as a platform is to make it as easy as possible, and I've really enjoyed showing off the great work by other developers that have already been able to be done. It came out this year at NAMM in March, and since then we've had a few new developers join, a few new effects come out on the platform. So we're really hoping that we've inspired some new people today to consider trying this out and creating a unique software effect, and then bringing it to life on a real-time embedded hardware pedal. So thanks so much.
And Shane did put the Shane does have he posted in the share your work channel on the Discord is where Shane posted about the offer and the full details of the offer, including the price there.
Sweet.
Yep. Link in the video description or on the Discord share your work channel.
Awesome. And one more question from me. So how long did it take you to actually create this platform from the starting point until now?
Great question. It is almost a two-part story because Steve, he's been working on Blackadder Audio for what, like 7 years now, since you founded that, and that started as the real first way to do teensy audio. And I started as a customer of Steve's, so that's a really nice piece of backstory. I bought his teensy development kit for my teensy board because I was playing with this exact type of thing. And then several years had gone by. Steve sort of became a mentor, and eventually we joined forces where Steve approached av8audio looking for a way to make a less developer focused product and a more guitar user focused product. And av8audio, we had this concept for the marketplace where we wanted to have that kind of flexibility that we see with plugins on a hardware pedal. And there aren't a lot of pedals that provide that. So we created this unifying platform between the Blackadder Audio hardware and the av8audio marketplace to come up with the Multiverse pedal. And it's aptly named that because it's a variety of different kinds of personalities that you'll find, different sorts of effects and brands on the one Multiverse platform. So Steve joined the av8audio team in 2021, towards the end of that year. And that's when we went from going from the the developer focused Blackadder product and started our development journey with Multiverse, and really at the end of 2021. Then we had prototypes that year and came out with a beta unit that we presented at NAMM. And then this year, at the beginning of 2023, is when we unveiled the developer edition unit and started selling it this year. And we have some exciting announcements coming up for 2024. We're going to be at NAMM in January in Anaheim.
Great. Yeah, we have some exciting announcements around NAMM and all of that as well coming up. So yeah, I will see you in California.
Oh, awesome. See you there.
Cool. So fantastic. Thank you so much, av8audio, Blackadder Audio. Really awesome. Fantastic ecosystem that you've created. Once again, if you're into creating guitar effects, be sure to check out the discount code. Hope to get some more creators on there. So thank you very much to both of you.
Yeah, thanks so much.
Thank you.
Great. Okay, so let's go ahead and continue on to our final talk. Here we have Brad House, who has joined us. So if you're familiar with the SFZ file format that's around the internet, it's a file format that's used to extend your sampler into a rompler. Brad actually has one of the leading ones on the internet called SoundFonts, and it's widely used. And he's actually a hobbyist, so he actually doesn't actually do audio full time. And it goes to show that there are many developers out there who actually view what we do here in the audio world as a hobby and something to engage in and have fun, and just to show expression. So Brad has kindly come onto the meetup to talk a little bit about the audio unit V3 format and how to start interacting with those APIs. So many developers ask about what goes on under the hood in Juice. How can you interact directly with some of the native APIs that happen on Mac and Windows? And so Brad is here to talk a little bit about the AUV3. He has an AUV3 template as well, and he's going to walk us through that today. So we're going deeper into the journey into audio development with Brad. So I will hand over the mic. Take it away, Brad. Thank you very much.
Hey, thanks for the nice, kind introduction, and glad to be here. So I'm not a professional audio developer, but I play one on TV, and I've done my first project was auto related, but it was actually in signal processing using the iPhone 3G, I believe. It was like, early on. Somebody wanted to take in inputs from the headphone jack and be able to do some signal processing on it on the phone. It was for monitoring the RPMs of an engine so that they could identify the optimal shifting pattern to use when they're racing using an iPhone. So that was my introduction into iPhone programming using Objective-C, but now I've moved on. So I'm going to switch over to a presentation. Let me share the screen real quick, and hopefully all this will work. All right.
Yep, you're all good. We can see that.
Yeah, of course. Now I have to... Yeah, so we're compared to the other presentations, there's going to be some more slides. But then I am going to go into a little bit of code and talk about the concepts that I'm discussing here. But I thought I'd do a little bit of a level set and first talk about some of the terms that I'm going to be covering. So on Mac OS and iOS, there's a thing called Core Audio. It's the lowest level, basically lowest level API that they both share. So you can do stuff in one environment and it goes over on the other one pretty much seamlessly. There's little caveats, but in general, it's a pretty nice system to use. Unfortunately, it's a C API. So if you're used to more, it's a pain. It can be a real pain, especially when you're used to object-oriented languages. There have been additions to it, and now there's this audio visual foundation, AVF audio. It's a higher level, which offers some really nice components that you can use immediately. So you've got an audio player, so you can just give it a media URL and it will start playing. You can tell it, when to play. You can cause it to loop, that kind of stuff. You can do audio recording, and you can also play MIDI files. It can set things up so that you're playing a MIDI file and it's going into a synth and background audio for your game or app. On an iOS device, it's unlike a computer. Really, you need to manage the audio hardware. So if you get a telephone call, you want stuff to fade out. If you're listening to music, you want to hear the call, or at least the announcement of the call. Maybe you ignore it, you want the music to come back, you want that to happen seamlessly, so they have an audio session and audio application components that help you manage that in your app. And then finally, there's this huge, great piece of software called the audio engine, which allows you to set up basically your DSP nodes as a graph. And it's basically akin to what you've seen in the previous presentations, where you're creating a directed graph between entities going from inputs to outputs. So that's also part of the AV Foundation. So that's the fundamentals, and that's what you get out of the box for in iOS or macOS. But we also have a concept of an audio unit, and this is actually something that you can create to do your own DSP in the AV and core audio universe. Now, there's two versions, essentially. There's AUV2, which is more of a property-based mechanism where you set different properties and you're communicating your audio unit via these properties to the system. And then you also register callbacks such that the system will then call into these routines to do the work that you want to be done. It's not that friendly, in my opinion, but it works. Then there's audio unit V3. And now this is where we get into a more interesting distributed, a more interesting way of, and a more object-oriented way of dealing with DSP kernels and plugins. So you can have filters, there's filters and effects. You can also do audio generation, such as instruments, synthesizers, and the like. You can also do MIDI filtering and MIDI processing in your plugins. This is using a pull model, which I'll show you in the code. So basically the last element, really the speaker, is essentially pulling in the audio up, going up the stream and asking, I need audio, I need audio. If you don't give me audio, then I'm gonna glitch. So you are always in somewhere in the stream, and you're asking your upstream component for audio to process if you're an effects plugin, and then you write that out, your updates, you write output. Interestingly, so AV2 really didn't quite, you could do a user interface, but it was separate. You had to manage all of this. But with the AUV3, you can actually provide your own user interface, and it's actually kind of tied and bundled together very nicely. However, it's not required. And there are still AUV2 components being sold, and you'll find a ton of them if you have Logic or GarageBand on your device. So now let's go a little bit into the AUV3 terminology. As you saw in the previous presentation about parameters, so you had a volume level and a delay. You can also have, or a low-pass filter frequency cutoff. You can do the same thing with AUV3, and they're defined as individual parameters when they live in this concept called an AU parameter tree. And this is the mechanism by which you communicate values between the user level, the user interface, and the DSP kernel that will be running. And it does this in a thread-safe manner, so you don't have to worry about locking anything or whatnot. You also have the concept of presets, just like we've seen before, and just like the Juice has. And you, again, like the other, everything else, you have to define a kernel. This is the code that's going to do your audio processing and generate and render samples in a real-time thread. Finally, I'm going to talk a little bit about a host, and this is, you're all familiar with a digital audio workstation, Logic Pro, GarageBand. But the application that I'm going to show you actually is hosted as well. So it actually demos your plugin and gives it a nice environment in which the users can explore and see what it does. Yes, so that's it. Now, Apple with AUV3, they brought about this, they made it, with AUV3, you can package your plugin up as an app into an app, which then is sold on the store. So this is the only delivery mechanism that you have to get plugins onto an iOS device. For Mac OS, it's a little bit more open, but the easiest is to do it via an app store. And it works exactly the same way on Mac and on iOS. So that's a nice capability. I have a link here for some additional documentation, but it's but basically all the app is a service, is a way of delivering the app extension or your AUV3 plugin to the device. And so now I'm going to talk a little bit about, I'm going to go into the AUV3 template that I created to make it easier for myself to create additional plugins. After I got the first one working, and I did another one, I realized there's a lot of commonality, and I wanted to refactor that out into a template that makes it easier to spin up new ones. So here's a Xcode. It's the development environment for Apple provides, and this is a template. This is my template project that is available on GitHub.
Oh,
it's my name.
Screen's black.
Oh, sorry. Thank you. Let me reshare the. Sorry about that.
It's all right.
I just do the whole screen. Okay, is that better?
Yep, there we are.
Right. Okay, sorry about that. So here's Xcode, and I've opened up the AUV3 template that you can find on GitHub. But what I'm going to do is create a new template, new plugin using that template, and the template itself comes with a Python script that will create a new one. So I'm in the directory of a.
Uh-oh. Did he freeze?
Yeah, I think we lost his audio for the moment.
Let's wait till he comes back. In the meantime, while we're waiting for Brad, be sure to join our community. If you're not on our Discord yet, what are you waiting for? Join our Discord. We have now over 10,000 members. It's free to join on the audioprogrammer.com/community. Is he back yet?
By the way, it was very easy to join. You just have to agree to the basic rules when you enter, and then one of the things that I liked when you get in there is there's a section that teaches you how to ask for help, because it's important to know how to ask good questions. So there's a section that teaches you how to do that so that you can ask good questions about audio programming.
Yeah, thanks so much. Yeah, it's sometimes I think once for people starting off, it's like being in a cave without a flashlight. And that was one of the things that we saw early on when people started joining the Discord, and we started getting some people in there asking questions, was just figuring out how can we guide people into asking questions in a way that others.
Sorry about that. My internet died.
That's all right.
Back.
We've just been vamping.
All right.
And we've just been vamping.
That's good.
Cool. Go ahead and share whenever you're ready.
Okay, so I believe I'm back.
Yep, you're all good.
Awesome. Okay. So in the template, it's going to create, there's 4 targets, and targets are essentially basically compilable or entities that you generate with code. So there's an iOS app, there's an iOS extension, which is the app extension or your AUV3 component. And then we have the same for Mac OS. So again, this is all set up for you. It's all there. Of course, iOS and Mac OS don't have the same frameworks to use, so it's a bit of a pain, but everything has actually been kind of separated out into this other package called AUV3 support. But I'll hold off on that for a second. Let me go into the code itself. So again, so with the template, you get both an iOS and a Mac OS app. It will run on either one, and your code is the same as far as the kernel. There's no change to that. The UI is a little bit different, but it's mostly cosmetic stuff. In the APM template or this new project that we have, we're using Swift for most of the code, except when we go into DSP. So this is a Swift package manager, simply something kind of similar to NPM package. So you've got a declaration of what packages you define, and this is defining all of the targets that will be built. So in short, we have our kernel, which will be in C++. We have a kernel bridge, which is essentially it's a legacy bridge between C, Objective-C, and C++ into Swift. And then everything else, parameters, parameter address, and I have a simple theme, but all of that is now in Swift language. So, unfortunately, you're dealing with 3 languages, or 2 if you forget you just kind of gloss over the Objective-C. But fortunately, the Objective-C stuff is very light, and it is legacy. That Swift Apple has a new package that's just been released, or a new way of with their most recent Swift. It allows you to essentially do seamless merge of Swift and C++. There's no more bridging necessary. It will talk directly to C++, as long as you do. You don't do too many complicated things. But the kernel itself is what you probably see in Juice, although there's going to be some differences, of course. But in short, everything for this is done in do rendering. So here we're told that this will be called every time the rendering callback needs more samples. And so in AU or in core audio, there's a concept of a bus, which is essentially just a collection of audio streams. There can be more, usually it's 1 or 2 for mono and stereo, but there can be more than 2. And then we have our inputs and outputs, and the number of frames we need to render. And then just like we saw in the previous some other code, we have essentially our parameters, and we then do some rendering of samples using the parameters. Now here I have it split out between 1 frame for rendering versus an open number. And that is due to the fact that I handle ramping. So this is when you change a value and you want it to slow the parameters to change over time with samples per sample change. That's what I'm doing here. There's other ways of achieving that, but this is the way I did it here, just as a demonstration. As I mentioned, there is C++, or well, first that's it actually as far as um, um, the kernel itself. You're just defining parameters, and essentially you're doing your rendering here. Everything else, more or less, is support of my render function, and then there's some initialization routines and that kind of stuff. But basically, it's all done. Everything else, the bootstrapping and the harness is done elsewhere. I know in Juice you see the virtual functions being used, and I took an alternate route and used what's called the curiously recurring template pattern, or CRTP, and that's basically where I'm passing in my kernel class into this event processor template. And that's actually defined in my AU support library. And what that does is essentially all these do methods are called by the event processor class, but they're in line. They're not going through a virtual dispatch. So it's a bit fast. Yeah, and that's pretty much it for the kernel. Now we go into the bridge. And essentially all it's doing again is providing very, very light translation between the C++ kernel and our Objective-C environment, which then Swift can deal with. In core audio, in AUV3, actually, we have these things called internal render blocks. This is part of the AUV3 AU spec. And this is what will be called by the core audio system when it wants more samples from your kernel. And so this is what we do to set it up, and this is our entry point into the code that I showed earlier, that event processor. But this is all generic. It doesn't really need to change for any of the if you have a new plugin. It's all boilerplate essentially. For parameters, and I talked about the AU parameter tree. This is essentially where I define the parameters. Again, we have an enum, just like we saw in the code before in the previous presentation. So we have an enumeration of the different controls. We have a definition that can be localized to different languages. So we have different parameters, and they specify units, whether or not they're log scale. So this is all stock, basically stock stuff from the AV Foundation. And some additional helper functions in Swift just to manage the, again, the stuff that we don't really care about. Over in the, it's kind of misnamed, but it's a configuration, but it's actually a preset. So for saving individual states of the app, we define what we want to save and how we save, and it'll handle the rest. AU V3 components support presets and factory presets. You can also obtain a string representation of a preset, or a blob actually, and save it in the anywhere. But Core or AV Foundation will also manage it for you. And yeah, that's basically it. Here's some presets that I defined for the factory preset values. So I can go ahead and real quick build, and hopefully everything works correctly. And let's see if it comes up. Now I'm building the iOS app, and it's going to be running in the simulator. And any minute. Oh, okay, well, it didn't pop up because it's full screen. So here is the view that comes up with it's a stock view. It provides a prompt if it's the first time you ran to describe what it is and what is now changed on your system. As I mentioned with the app extensions, this is the app, and we now have this available. Our plugin is now available to be used by any other entity on this iOS device. So this is a simulator, but if it's on a real device, you could then now use this plugin in GarageBand or Logic if you have it there, or Cubasis. And this is actually a host. So this host, although it knows about this plugin, it's actually not loading the plugin directly. It's asking the system to find the plugin that matches the type and the manufacturer that was defined when we created it. So it's actually emulating what it is like for GarageBand to load it. I could play, it'll also play sample here. No, I hear it, but I don't think you hear it. But you can change to the different presets, and you can define your own presets. You can add, delete. So this is all part of the stock AUV3 template that's provided. Now, one other thing is that Apple provides AU Val utility that's standard on all their Mac OS platforms. And what's nice is that it kind of gives you it submits your plugin to a lot of tests to see if it's going to load in Logic without having to even test in Logic. And if it doesn't pass this, it will not get loaded in GarageBand or Logic. So it's a pretty nice little tool to use for testing. But other than that, there's not a lot. It's kind of difficult to do debugging and problem determination on iOS devices apart from log files. So let me go back to presentation. Oh, real quick. So I mentioned AUV3 support. It's again a collection of additional stuff that's helpful for working with AUV3 plugins. We got some of that parameter management that I showed you in the host is part of this class. It's got common UI code that I use. And it's got some C++ headers, which you'd see also in Juice. It's the same kind of stuff, much less. And by the way, and all the code here, and everything that I linked to is on my repo. They're all MIT licensed. So have fun. I mentioned DSP headers. This is what I use in my so far. The biquad filter is interesting because Apple provides its own biquad filter class. It's a high performance, very high performance. But this I use on just for playing around with. But in one of my apps, I actually use Apple's for speed. I already talked about the event processor again, and how it also handles MIDI. And the parameter changes are interleaved with the rendering calls, so you don't have to worry about that. You only get it. You'll only be asked to render n number of samples and then there'll be a parameter change, and then you'll be asked to render more samples, so it does the time stamping for you correctly. I have my own, as Juice does, my own little knob. The nice thing about it is using core animation, so that's the same between Mac and OS, so I don't have to deal with the UI kit versus app kit, that kind of stuff. And did the demo already. I mentioned troubleshooting with, so the AU val thing is the nicest thing to have, really. Debugging on iOS is a bit of a pain because the iOS app is actually a separate process. It's not that host process that you're running, so you have to connect to it separately. It works, then when it doesn't work, and then usually you have to restart your device. In macOS, you can actually run in-app, which can be very convenient for testing and for performance because you have reduced latency. But if your plugin crashes, of course, then you're taking the host down with you. So it's trade-off. And again, we already covered AU val. Finally, when I started, there wasn't a lot of documentation on core audio, and this one book by Adamson and Avila was like a godsend. It was like the first one that actually these guys just spent tons of time on the in the core audio API, and it's still a pretty good resource, but it is core audio. I used a lot for a lot of my plugins. I highly recommend Perkel's book, The Designing Audio Effect Plugins in C++. He doesn't focus, it's a generic approach. It's just talking about DSP, but the code is fairly easy to read, and he also he has a system for generating similar like Juice, but it's not nearly as full-featured. And then, of course, my repos have various additional links to the resources that I've been using. And that is all that I had to present. And I know I spun through it, but that's it.
Thank you so much, Brad. That was really awesome. Really great to see what it's like under the hood, and taking a look at what it takes to go outside of Juice if you want to interact with Apple's core audio APIs and associated APIs. I don't have any questions. Oh, here we go. So there's a question from Sketch Audio. So what are you using for UI? Are you using Swift UI or UI Kit? Also, what type of Mac app is produced? For example, Catalyst.
Right. So that's an excellent question. So right now, for the Mac, it is a native Mac app. It's not Catalyst. The UI is so right now it's native. So it's not Swift UI. It is UI Kit, and it is App Kit for Mac OS. But the controls that I was using, or the knob, for instance, is done in CA layer. And I'm working on, and I have a link in the presentation about a newer version which integrates the knobs with AU parameters. And that's all in Swift UI.
Amazing. And what's the actual difference between Swift UI and UI Kit? Just out of curiosity.
So it's, well, Swift UI is a declarative. It's basically it is you build your views, you declare your views, and you lay it out in a very terse style of declarative style, essentially. So instead of having to drag and drop little icon or little boxes and link them together, it's all in code, essentially. Swift UI is a way of describing your views in code. It's really not too far. That's basically it. A lot of the underlying the nuts and bolts of it, how you hook things together, is completely done under the covers. So it takes a lot of, and what's the best thing is the layout management. So where you'd have, so like here on my, an iOS device, if you rotate it, you have to, well, not that one, but, this is the app running in GarageBand, by the way, that app. So if I rotate my device, I have to rearrange things. I have to basically use layouts, and it will reorder things. But in Swift UI, all that is handled automatically, essentially. You still have some control, but a lot less. You don't have to worry about nearly as much. So it's I'm not very good at it, but it's something it's slowly learning.
Would you say that dynamic control? So there was a question from Brian Mendoza, who asks if there are any advantages of using these core APIs over Juice, and would you say that could potentially be one of the advantages, that having that access to that declarative dynamic layout?
No, I personally, I don't. My own reason was, I looked at Juice, was that I had to learn two APIs essentially. I mean, I did look into Juice, and I looked at the examples, but for what I wanted to do, I didn't see a clear path, and so I started to dig into some of the audio visual kits, Foundation and AV kits on Apple, to get to see what I needed, if they had what I needed to use. And then, yes, but then I have to learn that and then see how I'd map it back to Juice. So it's a trade-off. This stuff only works on Apple ecosystem, right? So that's the big downside.
Can I jump in here as well a little bit?
Sure.
Because I have some experience with this as well. What you said, if you're only focusing on Apple stuff, I probably would use the AUV3 as well, especially if you're just going for iPads and iPhones, maybe. Like Juice is great for cross-platform things. If you want to support Windows, Mac, Linux, iOS devices, Android, because you only have to write things once. But if you know you're going to just focus on iPads, it's much simpler to use the AUV3 APIs. And also, since you're using core animation, that's actually way more performant than the Juice drawing code. And it just gives a nicer experience to the user. And you could even use it on a Mac as well, because core animation also exists on Mac, and AUV3 also runs on Mac. So
Correct.
if I was just going to do iPad devices, I would just use AUV3 and not Juice.
Right. I mean, it makes sense. I mean, but I definitely don't think it's like it's better.
Well, I mean, AUV3 has things that Juice doesn't support right now. One of the contentious things is like parameter, a sample accurate parameter updates, for example. The AUV3 does have that built in. And they could add it to Juice as well, but that's one of those things you kind of have to wait for the Juice developers to finally do.
Right, sure.
I actually have a question for you, if you don't mind,
Sure.
about your implementation. So I've used the AUV3 stuff as well from Apple, and I started with their demos. Like they have these couple example projects to build a low pass filter or something.
Yep.
And I noticed that they don't work very well if you enable the thread sanitizer. And I don't know if they fixed it, but their parameter implementations, like I think the parameter tree thing, you have to basically, you provide the storage for the parameters, I think, right? So you provide the variables, and they just say the parameter has changed, and then you need to store it somewhere. And maybe they fixed it since then, but they didn't use like atomic variables. So if you use the same parameter, if the parameter update comes from like the UI thread or something, and then you use it from also from the audio thread, you get like a thread sanitizer error. So did you do anything special there? Do you like use atomic variables to back your parameters, or?
No, so you're correct, and I have seen that. And in my state, it's not even part of the AU parameter tree, but I have the AU v3 component the audio units support a bypass function, and if you can enable, disable, and actually this host supports that too. There's a little button that if you push it, it will disable the plugin. You're just hearing normal audio, unfiltered, enhanced audio. And when I would do that, I would get that little warning. All of a sudden, Xcode would light up, like I'm not doing something. I'm basically changing state that's unsafe. And so there, yes, I did change it to a atomic bool. Now for the AU parameter trees, you don't need it because, well, you probably may do. There's probably plenty of situations where you do, but the parameter changes actually come through in the rendering process.
They're
so they're
like
interleaved,
events, right? Yeah,
yes,
like MIDI, basically.
Right. And so there you're separate, and furthermore, you're really isolated. You're on your own little separate little place, and when you present a UI, you can, of course, you can do whatever you want, and you can reach in and kind of get really nasty. But if you just do with the parameter tree, and if you honor that, so that your changes are going through the render loop, so you're posting changes to AU parameter tree, and you're not reaching in and trying to display values from your kernel, then you'll be all right.
Right. Okay. Right. So you have to be very careful to keep them separated that way.
Yes.
Okay.
Yes.
Cool. Thanks.
And it's not and you're right, the sample code, that LPF, the low pass filter code, for instance, has that. It's and it doesn't pass the AU val utility either. So
well, it's good that you have your code as a better example.
yeah.
Fantastic. So Shane asks if you have any apps on the App Store that we can use to test some of your audio effects and where we can find them.
Sure. I mean, it's on. So I don't know if so all the apps, I can put them. I don't know how to. What's the best way to share that information? But on the App Store,
if you
just search.
If you type the link to me in the chat, in the Zoom chat, then I can put it onto the YouTube chat and onto the video.
Okay.
Yeah.
Okay. But if you search for sound fonts in the App Store, you'll find, that's the most, and then it has a link to all the other apps that are available. Also, the sound fonts app is available on GitHub too. It's MIT, even though it's for sale on the App Store. If you want your own copy and you're comfortable compiling it, go ahead.
That's awesome. Fantastic. I think that's all of the questions that we have. Thank you so much, Brad. We may need you back to go through the sound fonts app at some point. We'd love to check that out sometime.
Sure. I mean, I'm still trying to. Well, it needs a lot of work, but it's been fun.
Great, cool. So I think that's where we're going to wrap up today. Thank you so much for giving your time and your afternoons and evenings for the meetup. Much appreciated. Thank you to Matthijs, Shane, Steve, and Ryan, who had a work engagement from Aviate Audio, but he's with us in spirit. So thank you so much. Thank you also to the people that joined us for the meetup. Really awesome meetup. A lot of creativity. It's an exciting time for audio software development right now, and for hardware development as well. So with that, we'll go ahead and sign off. I always wait till the last minute to announce when the next meetup's going to be, but let me just put it here. So 9th of January is the next meetup, and we already have some guests that are going to be joining us. Very exciting. But for now, we're going to go ahead and sign off. Happy holidays to everybody. This is the last one where we're going to see you before 2024. So yes, we hope that you stay safe out there, stay coding, and we will see you in the new year. And with that, we will go ahead and sign off. Thank you very much.
Thanks a lot.
All right.